Simplifying radical expressions. First, we're going to look at the radical. So if we have a radical, a, n, x, this a is called the coefficient. This is the radical sign. This is called the radicand. And this is called the index. And the entire thing is the radical. It's important to use all of these terms when we are working with radicals, because it's just like English has a language, math has a language as well. First, we're going to work with evaluating radicals, so all that means is we're going to type it into our calculator. So, if you have a Sharp calculator, you're going to type in for this one, 3, second function, yx, negative 64. I don't need to put that in a button. If you type that out, you should get negative 4. Or if you look at the side on the chart, you can see that 64 is the cube root of 4. The 4 is the cube root of 64. There we go. And the way you would read this is the cube root of negative 64. If you have a Texas Instrument, you should type in negative 64, second function, yx, 3. It's backwards. And some calculators, instead of having the yx button, have a button that looks like this. You do it the same way with these, but you don't have a yx button. So play around with your calculator. Make sure you know how to use your calculator. For the second one, the square root of 121 is 11, and the fourth root of 81 is 3. Now we're going to work with mixed radicals and entire radicals. So a mixed radical means you have a coefficient in front, and an entire radical means everything is under the radical. So to bring a coefficient into the radical, you have to raise it to the power of n. So for our first example, we have 3 root 2. If there is no n, it is the same as 2 because it is a square root. To bring the 3 under the radical, we have to raise it to the power of n, which is 2. Now we simply simplify, so 2 times 3 squared is 9, times 2 is 18. To bring the 4 under the radical, we raise it to the power of the index, which is 3, so we have 5 times 4 to the power of 3, which when you type it into your calculator or do it in your head, 64 times 5 is 320. To bring this 3 under the radical, we raise it to the power of the index, which is 4. 7 times 81 is 567. Okay, to put it as a mixed radical, we need to break up the inside. So I'm going to show it 2 ways. The first way is to use the chart on the side. So you first need to look for a square term that goes into 162, and that number is 81. So it's 81 times 2. Now you're going to break this into 2 separate radicals. Now you can take the square root of 81, which is 9, and you can't for this, which is 2, so your final mixed radical is 9 root 2. Another way to do this is to do a number tree. 162 breaks into 81 times 2. 81 breaks into 9 times 9. Because we have 2 9s, they can come out. We have a 2 left by itself, it stays under the radical. For 24, a number that goes into 24 that is a perfect square is 4. So 4 times 6. Split it into 2 radicals. You can take the square root of 4 to be 2, so we're left with 2 root 6. If we were to do a number tree, you can split it into 2 times 12, 2 times 6, 2 times 3. We have 2 2's, so it comes out. We have 1 each of these. You times them together, 2 times 3, and put them under the radical. Either way you do it is fine. Both work. For this one, we have the cube root of 686, so now we're looking for a cube number that goes in, which is 343. So we're going to break it into 343 times 2. So the cube root of 343 times the cube root of 2. And because we can take the cube root of 343 to be 7, we're left with 7 cube root of 2. If you did this as a number tree, you could go 686, 343, and 2. 7 times 7 times 7 is 343. So we have 3 7's, so they come out, and 1 2, so it's left underneath. So when you have a cube root, you have to have 3 of something to take it out. With 72, 8 goes into it. 8 times 9, the cube root of 8, times the cube root of 9, so 2 cube root of 9. As a factor tree, it'd be 72, 8 times 9, 3 and 3, 2 times 4, 2 times 2. So we have 3 3's and only 3 2's and only 2 3's. So you multiply them together and put 9 underneath.